Problem 12. F of x equals the square root of x plus 6. We have 6 different problems. The formula for the composite of f of g, formula for the composite of g of f, the domain of f of g, the domain of g of f, the range of f of g, and the range of g of f. Problem 12a. The formula for the composite of f of g is the square root of 1 over x plus 6, simply because all you have to do is take the x value that's in f of x and replace it with the initial value of g of x. So a simple plug-in will get you this response. Simple and sweet. Problem 12b. The formula for the composite of g of f is, answer, 1 over square root of x plus 6. And similarly to the previous problem, all you must do is input the value of f of x into the space where x once belonged in g of x. So again, basic principle is this, your answer. Not much work to be shown, just a simple plug-in. Problem 12c, the domain of f of g. Remember, f of g is the square root of 1 over x plus 6. We know that it's not possible to find the square root of a negative number. So in knowing that, if we plug in negative 1 over 6, we find out that the square root of 1 over x plus 6 is equal to 0. But any negative values between negative 1 and 6, negative 1 over 6, comma 0, we know that will produce a negative number under the radical square root. Also meaning they cannot be solved without an imaginary number. We also know that any value between negative 1 over 6 and 0 will produce a negative under a radical, as said earlier. So our domain excludes x values between negative 1 over 6 and 0, but can still equal those two. So therefore, the domain of f of g is negative infinity, comma, negative 1 over 6 inclusive, union, exclusive 0, comma, infinity. Problem 12d. The domain of g of f. Remember, g of f is 1 over the square root of x plus 6. So again, we have to ask, what number can be plugged in that will equal the denominator to 0? That number would be negative 6. Anything more negative than negative 6 will produce a negative under the radical, which cannot be solved without imaginary numbers, like said before. Therefore, the domain of g of f is negative 6, comma, infinity. Problem 12e. The range of f of g. Remember, f of g is square root of 1 over x plus 6. Now that we've already found the domain, we must input all the x values found to find the range. When you input negative infinity, your output is square root of 6. And when you input negative 1 over 6, your output is 0. When you input infinity, your output is also 0. If 0 is inputted, the function is undefined, however, if you put 0 in, the function is undefined and not considered in the range. So therefore, the answer is 0, exclusive, comma, infinity, union, exclusive, square root of 6, comma, infinity. And that's your answer. Problem 12f. The range of g of x is 1 over the square root of x plus 6. To solve for range, input the values from the domain of g of f into the function. When negative 6 is put in the denominator, you come up with 0 in the denominator, which means y cannot equal 0, or 0 exclusive. Every value that is greater than 0 that is inputted can be possible. And that goes on infinitely. So you find that your range is 0 exclusive, comma, infinity. And that is your answer.